All right, so we're just going to review kind of what we did on Thursday. To start off, it says, when do we use implicit differentiation? So it's really easy to tell when you look at an equation whether you're going to have to use it or not. Essentially, your equation will not be solved for one variable. The other way you could say it, your variables will be mixed together. That's how you can tell. If I give you y equals 2 cosine of x, you don't need implicit differentiation for that. But if I mix the x's and y's together, that's when you notice you'll have to use it. What are the steps? Well, first, take the derivative of each term with respect to the variable indicated. Someone raise their hand and tell me, how do I know what the variable indicated is? Raise your hand if you know. Travis, what do you think? It's the one in the denominator. So you'll have d something over d something else, and we'll put that in our notes here. And just like Travis said, d something over d something. This is the with respect to variable. So you have to respect that denominator variable, okay? That's step one. After you're done that, when you're solving for something, pretty much whenever you're trying to solve for a variable, what's your goal? To get the variable all by itself. And this one's going to take a few steps to get it all by itself. But if I want it all by itself, you got to at least get them all together. That's the key. So collect all terms with the indicated whatever that is. So if I ask you to solve for dy dt, everything with a dy dt goes to one side. If you don't have it, take it to the other side of the equation. So you're moving terms around. You're trying to get all of them together. So to describe where we are right now, on the left side of the equation over here, every single term has a d something. So let's call it dy dx. All of them have a dy dx in it. So if every single term has a dy dx with it, what can we do if all of them has it? Take it out. That's called GCF factoring. So GCF, now that they all come out, you're going to notice every single time the very last step was to divide. When you're done that, just simplify. Double check that you simplify completely. So if your answer becomes 2x over 2y, please simplify the 2's. Okay? So that's pretty much what happens every single time. While you did your homework, you should have noticed every single time you kind of had to do the same steps over and over and over. So, things to remember when using your implicit differentiation. Make sure that you understand what you're solving for. This is the key. You want to know what you're solving for. Can someone explain in words, how do we know we'll have it? This is called a differential. What's an easy way to describe to someone else that you'll have a differential? We went over that on Thursday also. Because we don't always have them, but sometimes we definitely do. Yes? Yes. If you're taking the derivative of a variable that is not the with respect to variable. Are you purposely switching seats? Yeah. No, I can tell you guys. I can tell twins apart. I just sometimes takes me long to get their names connected, but I figured that was the point. Really? Your teacher knows you. All right. Ty, what's up? Oh, yes, I know them very well apart. Okay. So that's one other thing you want to write down. That's adorable, by the way. I like it. So cute. All right. So, if the variable you're taking the derivative of is different from the respect to variable, Okay, that's the other thing you want to write down there. I'm not going to write it. You should have already written it. All right, that's a little summary of Thursday. Okay, that's our mini review. Let's double check that you knew what to do. So there is a problem underneath there. Can you guys work together at your tables? Work efficiently, quickly, because I don't have that much time. So equation of a tangent line. Two things are needed. Raise your hand if you know one thing that's needed. Raise your hand if you know both things that are needed. Why do I see no hands up? So I'll ask it again. Raise your hand if you know there's at least one thing. Raise your hand if you know both things. All right. So, what is one thing? Kevin. You need the slope. Ruth, what's the other thing we need then? You need a point. All right. So based on the problem that is here, give me the point. -1, 2. The slope. If you're using x and y's, what's the slope's differential? Differential. dy dx if we're using x's and y's. Danny's question was, how do I know which one? That's how you know. You are just supposed to know that if you use x's and y's, slope is always dy over dx. Alright, so at this point, most of you should be pretty far through. I'm going to start writing down a little bit of the work. Alright, can you guys look up for 1 second? Because there is another answer that you could have gotten. Please don't furiously copy down my work. Please do not furiously copy down my work. You should still be working if need be. You will get to a derivative. This is one answer. There is one other answer that will be accepted. It is if every single term has been multiplied by -1. So let's talk about simplifying or makeovers. If I multiply the whole entire thing by -1 over -1, have I changed my problem? No, I have not, because what did I actually multiply by? What's -1 divided by -1? 1, and if you multiply by 1, are you changing the problem at all? No. So that's why it works. How does it happen? How could you possibly not have the same answer as me? Do you notice I kept my dy dx's on the left side? You'll get the other answer if you move your dy dx's to the right side. If you decide to move your dy dx's and isolate them on the right side, you'll have the opposite answer, which is fine. That opposite answer would be positive 2x minus y over positive x minus 2y. How can I tell you're wrong? Because mine look like this, yours don't look like this. One of them's negative, but the other one here might be negative. You mixed it up. I can tell you lost a negative somewhere. So back it up to the beginning, because I watched some of you furiously copy. There's no need for you to be copying, because you would have practiced this all on Thursday. So you should be able to do it. Up here, double check that you have the -x dy dx. Please check your work. Don't assume you got it right. Check if you have a -y. Those were the two things that you had to get the question correct. If you don't have a -x dy dx and a -y, you're forgetting this. I would separate the terms this way instead of keeping the negative out front. You're forgetting to distribute. In each class, half of you forget. So, figure out a way to remember. I would do this. I would separate the terms and leave the negative with the x. So you get up to here. Someone raised their hand and let me know, what should I do now that I have my dy dx? Danny? What's a better word? Substitute in the point. The point was -1, 2. So, that's just notation. That's my way of saying I'm doing the derivative, but at this point, you should know notation, so I'm showing that to you because it looks confusing. And then I don't care which one. Most of you probably have this answer. So I'm going to substitute -1, 2. So -1 goes here, that's +2. +2 goes here, so that's +2. -1 goes here, so that's +1. +2 goes here, so that's 4. And we get 4/5. So, is that the answer to the question? No, it is not the answer to the question. I can actually fit everything on this page for once. You find the equation of the tangent line. So the tangent line would be y minus the y of the point. Good. How much is my slope? Oh, this. X plus 1. And then someone raise their hand and help me out with my normal line. What do I need to do to go from my tangent to my normal? Isaac? I did say raise your hand. Isaac? Negative reciprocal of the slope. What you'll notice, nothing else changes. Nothing else changes. Question. Can I do the same thing, opposite reciprocal, in slope-intercept form? Y equals mx plus b. Thumbs up if I can. Thumb down if I cannot. Thumbs up if I can. Thumbs down if I cannot. Okay? The answer is you cannot. You cannot. You cannot just switch the slope. Why not? Because your y-intercept probably changes. Think about it. Think about a line. Make a line perpendicular. There's a very good chance your y-intercept, let's say the y-axis is here, does it make sense that your y-intercept will probably be different? So no, you cannot just switch the slope-intercept form with the slope. That is why we tell you not to use it. Slower. So this is the way you want to do it. You just point slope form. Alright, so that's done. Cool. I finished it on one page. Alright. We're going to do more intense implicit differentiation. What I would like for you to do is, on this page here, I want you to find the first derivative, because this is asking for the second derivative. Find the first derivative to start. Any questions on the first? If you have your 6 and your 6 still there, can you please simplify it out? You want this step to have the simplest form. It makes the rest of your work a lot easier. So if there's still a 6 and a 6, cancel them please to 1, because you want it to be simple. It makes the rest of your problem simpler. So, this, the way it's written, is not a mistake. Those 2's are in those spots particularly. That means you cannot switch them. So to find the derivative of this guy right here, it is d with a 2, y over dx with a 2 here, squared. They look like squares. That's how we write the second derivative. And if I wanted to write the third derivative, they would change to 3's exactly in that location. No, you cannot move the 2's to other places. That's the notation. So, I took the derivative of the left side to make the second derivative. How do I take the derivative of the right side? Quotient rule. Do your quotient rule. Pause there. Jasmine, how do you say the quotient rule? How do you say it? Yep. Beautiful. Anyone have another way to say it? Ruth? All right. Anyone have a third way to say it? We're good? That's the 2 different ways? All right. Awesome. So, low, d of high, minus high, d of low, all over low squared. And then I would say this can't be your answer because you can't have a differential in your answer. This thing can't be there. Someone want to raise their hand and show me how I might be able to get rid of it based on what's already on the board. Now you two know. Put your hands down. Based on something that's on the board, what could I do to get rid of this dy dx? I don't want it there anymore. Right? What do you think? I could substitute. Didn't we find what dy dx was? Right? So, if I found it, then I should be able to use it. Okay? Simplify it completely. Check your rules of simplifying to see if you're completely done. It will take a few steps, but I want it completely simplified. Don't stare at me, please. Do your own work. Alright, so most of you are kind of at around the same place. I have this guy here that has a divided by y, and then I have another fraction. I have a stacked fraction. A fraction on top of a fraction. It's always the same step to get rid of a stacked fraction. What should I do with the numerator? That's the first part of the process. If I want to get rid of the stacked fraction, I should work with the numerator first. What do? You make a common denominator. It is always the same step. If you tried to separate your fractions, fine, but your answer will not be simplified because you have separate fractions. So I don't separate them. So the numerator, what's the common denominator of the numerator? Y. So I'll multiply this by y over y. So what do we get? 2xy squared minus x to the fourth all over y. All over y squared, true. But what can I do instead of making that stacked fraction again? Multiply by 1 over y squared. If you multiply by y squared, then you changed your problem. Dividing by a number is multiplying by its reciprocal, not multiplying by itself. That's what I have. That's what you should have. And then from there I get 2xy squared minus x to the fourth all over y cubed, and I would argue that you can do one more step. Take out that x that's in common. Can I take out a y here, y squared, and then leave only a y at the bottom? No, because they're connected. Good. Connected with that x cubed. All right. You have to be able to simplify. These are steps that you learn in Algebra 1. I teach you the calculus. You have to be able to do the other parts. Okay? Those pieces are always the same. If you want to get rid of a stacked fraction, common denominator is always what you do to get rid of a stacked fraction every single time, right? Yes. Simplified form means factored completely, one common denominator, no negative exponents. Can't remember what else I gave you in that list, but you go through that list. Okay? All right. Now that we did that, I actually want to add another problem, which is not in your packet. Find the second derivative. Put it on that same page. Put it on the same page. Okay? You don't need that much space. This one goes by pretty quickly. Find some space on that same page and try this guy. Second derivative is what I want. Find the second derivative. All right, let me get you down to the same place you all are. 2x plus 2y dy dx equals 0. I believe most of you have dy over dx is equal to negative 2x over 2y. What did I say about this step? To make the problem easier, what do you have to do? Simplify. Don't leave the 2's if you don't need them there. Check if you got rid of your 2's. They're just going to give you trouble later if you don't simplify it all the way. D low, d of high, minus high, d of low, all over low squared. Low, d of high, let's see, over y squared. We had an answer yet? I'm looking to see. Beat you up, Ty. Don't copy my answer. Travis, stop copying my answer. Not big enough to cover it all. All right. Let's check your final answer. Thumbs up if you get the same final answer as I have. And then thumbs down if you don't. If it's moved around, you put your X's first, that's fine. This is what I got. All right. Thumbs down if you ended up with something a little bit different. If I kind of backtrack through, double check that you did your quotient rule correctly. And subtracting high times derivative of low, that's where the negatives canceled. Oh, wait. They should have made it a plus. Did I do something weird here? I did. No, I didn't. That was right. So this turned positive. X here. And then this comes from substituting in my dy dx. That's how we can make sure we don't lose our negatives. There we go. There's my answer. And then all of you with the thumbs up would still get the problem wrong. Because I'm actually not done yet. Okay? So, oh Lord, Tiffany, why don't you just repeat what you said for me? I can simplify the y, so take 2 here, take 1 here. Tiffany said simplify the y's. Take 2 of them here, so then I get negative x squared over y. You told me to take out the y's. Come on, quickly, respond. Yes. No. Someone help her out. Ty, help her out. They're connected by that negative x squared, so can you ever cancel when they're connected that way? No! So I'll give you the step. Most people don't see it. Take out a negative from the numerator. Factor it out. I'm going to put them back in alphabetical order. So the x squared is going to come first. The y squared is going to come second. All over y cubed. That's still not the answer. Something should look familiar. Where have you seen x squared plus y squared somewhere on this page? How much is x squared plus y squared? How much is x squared plus y squared? 25. So, what's your final crazy answer? Negative 25 over y cubed, and that's the answer you would see in a multiple choice question. You won't see the original one you finished with. Did I do a second substitution in my other example? No. So will you always do a second substitution? No, you won't. We didn't do one for example 1. We did one for example 2. I asked you the common sense question, which was, will you always do it? The answer to that is no. Why not? Because I gave you an example of one that you didn't. So the answer has to be no. Use logic, people. That is why I gave you 2 examples. Because what you guys do is when you see something like this, you do it to every single problem. How do you know to do it? It has to make your answer look simpler. It must make your answer look simpler. If you try to do it with the first one, it may not do that. So don't you dare try to make every single problem exactly the same. You have to use some of that brain of yours to check mentally, does it make it simpler? In this case, it did. That's why we do it. Looking at the next piece, find the point where the function has a horizontal tangent line. So first of all, it said find the point. How do I label a point? X comma y. So your answer better be an x comma y, not x equals 5. That's not a point. A point is always stated as 2 variables, comma, parentheses. Horizontal tangent line. Help me out. How do I find a horizontal tangent line? Derivative equals how much? 0. What do I write for derivative here instead? dy dx. So go. Go. What do you need to find? two possible answers. Both of your x's should be negative, or both of your y's should be negative. One or the other, no mix of the two. It's only two possible answers, one or the other. So now that I have my derivative, what did we want to do with it? Set it equal to 0. So I'm actually going to erase this or part, just so I have the room on this page. And set it equal to 0. So if I set this guy equal to 0, here's the equation I want to solve. This side is a fraction, so I'm going to multiply both sides by this little denominator guy. But what happens when you multiply by 0? It's still 0, which is why it's nice to do that. So you end up with this guy. And then I'll ask the question, two variables. Can I solve that for a point? Two variables, one equation. So we know somehow, some way, we better have to substitute. We're going to have to substitute what? What can I use to substitute? So I have this equation, not my answer. Ty gave us the fact that we're going to have to substitute. I need somewhere to substitute into. So I think I hear what you're telling me to do, which is solve for y. Okay, true statement. So I still have, I need it to go somewhere. Where could it possibly go? Look at the problem. Where could it possibly go? We all understand two variables, one equation. You have to have another one to solve, right? Right, where are you looking? Y equals 4x. Where do I want to put this back into? The first equation, the very original equation. How do I know I have to do that? What was my clue? In this equation that I wanted to solve, what was my clue? Because this won't always happen either. You won't always have to substitute it back in. How do I know I have to? So what here? Two variables. If this said negative 4x equals 0, would I have to do a substitution? No, you could solve it, but there's two variables, okay? So go. Put this back into here, the original equation. I think I have it on the next page. I can't remember. Bell's going to ring. I need you to stay until we're done. Won't be too much longer. Eyes up here, just double checking when you substitute in. Please use parentheses. Why? Because I should have parentheses 4x, whole thing squared. Because if you ended up with 4x squared, you'll get the problem incorrect. So you use parentheses when you substitute in. So 2x squared minus 4x squared plus 16x squared equals 9. What do I have? How many x squareds do I have? I think 14x squareds equal 9. X squared equals 9 over 14. How do I get that x by itself, Malky, one more time? Square root both sides, but it's an even root, so what do I need? Plus or minus, so I get x is equal to the plus or minus root of 9 over 14. The root of 9 is 3. The root of 14 we don't know. You do not have to simplify radicals at the bottom. You don't have to rationalize the denominator. You get to leave it like this. Go back to the original question. What did they want? A point. So here's the x. So what do? You're going to substitute back in. Look at the two equations we had. This guy and this guy. Which one's easier to substitute back into? The second one. The one that you used to originally substitute will always be easier. So I'm going to use this guy. So we end up with 3 over root 14, comma, 12 over root 14. There's 1 point. And what's the other point? Negative 3 over root 14, comma, negative 12 over root 14. And there's one last step. I need you to put a note in your notes. Okay? There's one last step. You only do this step if you have time. You will do the step for homework. On a test, you wait. Because it takes a lot of time, but it doesn't give you much in terms of points. It gives you 1 point. You have to check for extraneous solutions. How do you check for extraneous solutions? So, you go back to this guy and check if they work. Both of them. It's a pain in the butt to do. It happens really quickly. You see all the roots? Don't worry, they cancel because you'll either square them or you'll multiply root 14 by root 14. So they will cancel. It doesn't take much time, but it's a step you have to do to get the problem completely correct. But I only want you to do it if you have the time. Homework, you have the time. I want to see it done. On a test, you put a little star next to it, say check, move on, come back. It's a test-taking strategy. Real quickly, there was another question. So it says vertical tangent line. What's the slope of a vertical tangent line? It's undefined. So dy dx, which was, I gotta remember, what was dy dx? Negative 4x. Can someone read it to me? Over negative. Alright, so we want this undefined. How do I make a fraction undefined? Set the bottom equal to 0. Alright. Set the denominator equal to 0. How many variables do you see? 2. So what do I have to do? You do the same thing that you did before. Solve this for one variable. And then what do you do with this? Oh, stop using the word plug. Substitute back into the original. Is this problem any different? Is this problem any different in terms of work? No, it's just the definition that's different. The definition where you start is different. All the other work is going to look exactly the same. Your homework, you're going to start with finishing up number 18. In probably about 15 minutes, I'm going to Edmodo you what to do as the second part, because if you do all of 19, it's too much. So I'm going to have you guys do some weird mix of problems. So if you want to get started right away, you're going to finish number 18, and then I'm going to give you part of 19 to do, not all. All right, that's it.